Okay. Hello, good afternoon, everyone, and welcome. Before we get started, I'd like to let you know that today's session is being recorded and the recording will be uploaded to our YouTube channel after. We'll also share the link to the video with you after. If you have a question, there's a couple ways to ask the question. You can either type in your questions using the Q&A function here, or feel free to unmute yourself to ask a question. It is my pleasure to introduce our instructor for today's session, Jacob Boucher. Jacob is a senior systems analyst with UBC ARC. He began his systems administration career at the South Dakota School of Mines and Technology, where he maintained the campus research cluster while completing his PhD in physics. His research background includes quantum computing and computational modeling. And with that, I'll hand it over to Jacob.
Thank you, Rachel. So today we're going to talk about one of the services that we have on offer as part of the UBC ARC Sockeye system. The service is known as ARC OnDemand, or more commonly known outside of UBC as Open On Demand. Before we get going, I just want to highlight a few of our other introductory courses that we'll have coming up in the next few months. The next one will be on Tuesday, March 17th, and that will be an introduction to the Bash command line interface and give a brief overview of how to use basic command line tools that may help you with doing work and operations on the Sockeye system. Later then in April, on the 14th, we'll have an introduction to cloud computing, and this will give a basic overview of cloud resources, both available for academic and research use, such as the Digital Research Alliance, as well as systems that are available from the institution and potential commercial cloud interfaces. If you'd like to register for either of these courses, you can follow the link that's on the side, and the link should be clickable right now over the Teams interface. So I'll give just a few seconds in case anybody wants to click on it. Okay, so to start us off, a little bit about the background of UBC ARC and the Sockeye system. Currently, we're supporting over 2,000 researchers across over 400 research allocations on our system. And we need to provide assistance and access to both our on-premise systems, such as Sockeye, as well as help support researchers who want to get access to the Digital Research Alliance of Canada's systems, and instruct them on how to utilize those systems well. Sockeye is our on-site HPC system that we manage and is available free of use to all campus researchers. The system itself composes of about 15,000 CPU cores and 100 GPUs. The system's been deployed in operation since the fall of 2019. And I believe at this point, I need to update my slides a little bit, but it should be over 6 or 7 million compute jobs run since the start of the service. Our primary system that's being utilized for scheduling is the Slurm scheduler. Now, if you're familiar with other HPC systems and Sockeye, generally what you'll be wanting to do is you'll connect over an SSH interface and make most of your interactions via the command line. So if you're familiar with the command line and have done a lot of work with it before, this isn't too bad. And generally, if you're in research, a lot of your software may have background with using command line tools. However, a lot of more modern software is much more GUI heavy and more similar with using either web or clickable interfaces. And that's something that HPC for quite a while has not been that good at handling, because you're expected to do most things over an SSH interface. So outside of some of the historical research software that maybe have developed in, say, the 80s or 90s and is very built on it, not a lot of researchers who are utilizing newer software have as much experience with using the command line interface. So the service that we've started offering as part of Sockeye is known as ARC OnDemand, and it's built on top of a system called Open OnDemand. And this is a web-based HPC interface with a more modern GUI design. Originally, it was developed by the Ohio Supercomputing Center for their use and has been made open source and available to install and modify on pretty much any system. And this provides our researchers an easy way to do some of their common tasks on the HPC system, such as moving and uploading files, submitting jobs, working with the scheduler to look at their job completion, interacting and starting a command line interface, and also utilizing graphical software. And I'll get to that point a bit later on what we're doing to develop that aspect of our system. But first, I'll go over some of the more basic features that we have available. So to start this off, I'm going to switch over to a web browser and show how we log into our ARC OnDemand interface and a little bit about the dashboard overview. So we can see here, I have a new browser. And if I do type in the site, our link is ondemand.arc.ubc.ca. And when we log in, we'll be presented with a login portal that's very similar to most other UBC pages. And in here, we'll need your CWL and your CWL password. Once you log in, it may prompt you to enter an MFA credential. And then after you've successfully authenticated, it'll take you to this main landing page. And from this landing page, we have our basic message of the day and a link to our technical user documentation if you'd like to review anything about our ARC OnDemand service, as well as a navigation bar across the top. To start out, we'll go ahead and we will look at the files. We can see here, I'm a member of a number of different allocations. So each of those allocations gives me a link to that allocations project and Scratch directory, as well as my home directory. So in my case, I'll just navigate to the home directory. And we can see we have a basic web view here with all of my directories and files for my home directory, as well as a number of interface buttons across the top here. So first off, I can look at, so say I want to go to a very specific directory. So in this case, I know, oh, I have something in my project. Well, my project is here on the side as a quick link, or I can also click here to change to an exact directory. So say it was in my project, and I want to just navigate there. And that will take me directly to wherever I typed in. As well, I can also click and navigate through the directories down below. So I'd like to navigate here. And then from here, we can see on each of these files, we have a name, a size if it's not a directory, when they were modified, as well as the owner and what's known as mode or the Linux permissions. And each of these is a sortable column. So say I wanted to see what was most recently modified here, I can click and sort via this column. Additionally, across the top here, we have some interfaces that we can use to either generate new files or new directories, upload or download files, and then interface with the Globus or modify and move files on the system. So as an example of uploading, I'll just go here and click the upload. It'll prompt me to either drag files in from my own file browser, or I can click on Browse Files, and it'll give me the opportunity to search, pick a file, open it, and then trigger an upload. Generally, because this is going over the browser, this upload is best used for files that are 1 GB and smaller. If you start having very large files, you do run into the risk of it can take quite a while to upload, and if you close the browser during the upload, it will cancel it and you'll have to start over from scratch. Another one of the services that we offer, if you'd like to use large file manipulation, is the Globus button, which I'll get into in just a moment. Similarly, if I'd like to download something, I just mark the tick box for it and click download, and it'll open and allow me to save something to somewhere on my system just via the download. And I'll again use the standard browser feature for downloading. Now, I mentioned there's a Globus button, and if you're familiar with the Globus interface, this provides you a nice, quick, and easy way to connect, log in, and utilize Globus from whatever directory you're in. So in this case, I'm inside of my project directory. If I click on the Globus button, it'll start a Globus session for Sockeye. It will probably prompt me to authenticate. And then once it's authenticated, it will connect me to Sockeye, drop me into the same path as where I was, and I can use that to either move large files in between, either directly upload or download from my system, or say if I wanted to connect to another Globus-enabled storage endpoint, such as a Chinook allocation or possibly a Digital Research Alliance system, or maybe a lab instrument or storage system, I can set that up as the second one here. Going through the details of how to do file management within Globus is outside of what we're going to go over today, but I just wanted to show you how easy it is to find something, open on demand, and then jump to using Globus to do a file transfer. Since we've gone over how to upload and download files, if we want to, say, move some files around, I could make a new directory. We can see that just got created. And let's move this file here that I uploaded. So to do that, you click copy, and then it'll pop this up on the side. And then wherever you navigate to, it'll either allow you to copy and make a second copy of it, or you can click the move button and it will transfer that file from the original location to wherever you are in your current directory. Similarly, if I want to delete files, I can click here and delete. It'll prompt me to confirm and then delete that file. The last button here that I'll go over is this Open in Terminal button. So say I'm working on something and I have some command line tools I want to use somewhere, say want to be in this directory. If I click on Open in Terminal, it'll open a new tab in my window and give me a prompt. And we can see here that it places me exactly wherever I am in the file browser. So I can do operations on any of the files here. Say we wanted to look at this, and I can open up a file to view it. Close. And this is just a good way if you'd like to start up a shell at a specific point somewhere in your files. I'll pause now and see if there's any questions about the file browser or anything that you'd like me to go over in more detail before I move on to the next section. Okay. So our next section is the job composer and our job monitor. We'll start with the job monitor. So if we go here, we can see I have a job that's currently running, and it's in the queue and has used 20 minutes of time so far. And if I click here, I can actually see more details about that job. So say I can see when it was started, when it is expected to end, how much memory I've requested, as well as some other details, such as around what the job's name was, what the ID is, how many CPUs I've requested, and etc. This is also sortable much like the other fields. So if I had multiple jobs here, I could sort by these columns. And in the event that I wanted to see all of the jobs on the system that I can visibly see, I can change from my jobs to all jobs, and I can use the filter here to say, look at all the GPU jobs. And we'll see any job with GPU either in the name, in the queue, or the account. And we can see these jobs for another researcher. They've been submitted, and all of this information is visible and accessible on Sockeye itself using the SQ command. However, this provides a bit more detail, or a bit easier interface to look up those details in kind of a more comfortable web view. Beyond that, we have the job composer. Now, this allows us to effectively create templates for jobs, set up Slurm scripts, and then even submit them entirely from the GUI interface. So in this case, I've already set this one up, and we can see it's a fairly basic job here that I've submitted. And if I want to make changes to it, I can open it in the editor, and we have an editor right in the browser that lets me make modifications. So say in this case, I wanted 4 gigabytes of memory instead of 2, and I wanted 2 tasks or 2 CPUs. I can make those changes, save it, and then whenever I'm done after I've saved, I can just close out that tab, and it'll be updated here in the job itself. If I want to create a new job entirely from scratch rather than one that I've set up before, I can click here and either create it from a template, another job that, say I wanted to make a copy of one, or from a specific path if I have a folder already set up. So in this case, if I want to make a template, we have a few templates here that are available based off of the templates that we have on our technical user documentation. So in this case, if I want to create a GPU job, I can select a simple GPU job and click Create a New Job. And that will create a new folder here with this template job script in it. And I can go through and edit it as I see fit to basically build up my actual job script. Now, if I want to run a job, I can select it from here and say, let's say that one that I just modified here. If I click Submit, what will happen is it will get placed into the queue, and then this will update periodically and let you know how it gets, where it is in the queue, whether it's running, and if it's completed, as well as updating the folder contents here for information. And we should be able to see it here if I go back to the job viewer and look at my jobs and remove this GPU filter. And we can see here it is right now. It's queued into the system and is waiting for resources to start. And some of the details around it here. Additionally, because it's we've set it up here and it's one of our jobs, we can actually open it directly in the file manager to go back to the file manager and see the details about anything around the job. And it just finished. It's a very, very short job. All it does is say hello. And we can see here, it just updated in the job composer itself as it recognizes that the job has been completed, as well as listing the new output files here. That's pretty much the basics of using the job composer. It's very useful if you'd like a easy to use interface to build up your job scripts. And then with this interface, you can also use this button at the bottom for Open Directory if you'd like to jump to, say, your file manager and upload some data files or something that you'd like to utilize with the job. Now, before I go on to the next section, I'll pause here and see if there's any questions or anything that anyone would like me to go into more detail on for the job composer.
Jacob, just a kind of like a general question. So for HPCs, how do you choose between a CPU and GPU job?
Okay. Yes. So in our case, for our system, if we would like to use a GPU job, there's a few things that need to be set up in the Slurm script. The first of which is you need to put your allocation code with the -GPU at the end, and that lets our accounting part of Slurm know that you want to utilize a GPU, and it tracks that GPU usage. As well, you'll need to specify the double -GPUs and then equal to some number. Generally, this should be up to 4 if you're using a single node, as all of our nodes have a maximum of 4 GPUs available on them. Beyond that, most of it is set up the same way as a standard CPU job, just with those 2 additions to it.
Jacob, there's a question from Q&A from Sophie. So for the Open Directory button on the job submit script, would this be where, for example, we can attach a database?
So if it is a database where it is, say, a single file that you need to read in for loading with the software, you would be able to upload it here. If it's a remote database, say you need to connect outside of Sockeye to a database to pull data from, unfortunately, due to the way we have the system set up, you cannot connect to an external database that's hosted off of Sockeye itself. Does that answer your question, or is there anything else that you'd like to?
I think that answers Sophie's question.
Okay.
Thank you.
All right. So I will move on here. And the last section I'll go to before we get into the interactive applications is just this cluster section. This is an easy way if you want to start a shell at your home directory. So similar to how we could do it in the file manager to start the shell at a specific spot, this will just start a general shell at your home directory. So we can see this is at my home. And this is probably the easiest way to just launch a shell if you want one via the web interface to interface and do any commands that you need to do over the command line. So now I'm going to go and discuss a little bit about our interactive applications. So we can see here when I click on the interactive apps, we have 4 options from the pull-down menu. First one is a cluster desktop, which is a basic desktop as you would find on, say, your home desktop for your local system. It allows you to be pretty open-ended on what you'd like to run. If you have some graphical user software that you need and you're comfortable installing it and saying, oh, this is a great way to launch it and utilize the VNC capabilities of ARC OnDemand to connect to it. Our other systems down here are more specific to exact pieces of software that we have on the system. So if you'd like to run a Jupyter notebook, a MATLAB session, or an RStudio session, each of those has its own interface, and I will walk through utilizing each of these here. So if we start up, we can look at a cluster desktop, and we can see here I've got a couple of options. The first will be selecting my allocation code. So much like I mentioned previously on the CPU and GPU listings, you'll have your CPU code, which doesn't end in -GPU, and then you'll have a GPU code that is specific to utilizing your GPU systems. So if I'd like a CPU one, I can select my basic allocation code and make sure I have selected a CPU node. After that, I can request a certain number of cores. So just so I have an easy to start one, I'll request 2 cores, and I'll request just 1 hour. You can request up to 24 hours on this sort of job, and that is simply to ensure that we have enough resources and they're available pretty frequently for all the users on our system. We don't want someone to request a full node and then take up a week worth of time while it sits idle running a desktop. Finally, if I'd like to have the system send me an email when my job starts, I can click here and it will send an email to my CWL at mail.ubc.ca. Once I'm ready, I can click on this launch button and it will start up and create a cluster desktop session here. We can see once it's queued, it sits in the queued state as it waits to get those resources necessary to start the job. Once it has those resources, it'll flip to the starting state and let you know that it's setting up the desktop and being ready to be launched. And then running state means everything has been set up, and it'll give us the opportunity to let us know what host we're connected to, how much time I have left on this job, some information about the session, and some details around using the VNC connection. By default, we use the web no VNC that's built into the browser. But if you're familiar with and you have your own VNC client that you'd prefer to use, we also have instructions on how to connect and utilize your VNC session this way. For this session, I'll just launch using the no VNC client, which will open up here. And we can see I have a pretty basic desktop. I can start a terminal here. I can view my files and navigate through them as if I was in a browser. And in this case, we can launch software that is more graphical based. And just because it takes a little bit to set up, I did start a session briefly before this that already has some graphical software loaded up. So I installed a copy of Blender for myself, which is a 3D rendering software. And we can see here, this is all running within the browser connected to compute system. So if I wanted to make modifications, I can go in here. Blender's probably not the best example. Some of it is a little intensive for the CPUs, but we can see here I just made some modifications, and it's just a good example of kind of what you can do with graphical software and this virtual desktop interface. Once I'm done with the session, I can just close out of the VNC session, and we'll have this delete button here. So if I no longer need the session, I can click delete, and it will end the job early and close it out. So I'll go ahead and close out these two. And we can see that they've disappeared from the menu here. So now along the side, we have some of our other options. These are the same that show up in the interactive dropdown here. So we can take a look at a few of the other sections. So say we have some Python workflow that I'd like to use a Jupyter notebook to work on. Once again, I can select my allocation code, how many hours I want to run for it, the node type, how many cores, and in Jupyter's case, we also get the option of either setting up a full Jupyter Lab session or just a Jupyter notebook itself. When I'm ready, I can click the launch, and it will, just as before, get placed into the queue, and generally will start pretty quickly as long as you have a small number of resources. So in that case, since we only selected 2, it probably should start here in about a minute or so. And we can see, once again, it's starting up. And once it's finished setting up the Jupyter Notebook, it'll provide me with a button here to connect to it. And we see this is a little bit different than the cluster desktop because our other systems here, rather than using VNC to connect to the system, have a built-in web interface. So in this case, if we click Connect to Jupyter, it'll pop up a in-browser Jupyter Lab tab that'll load up here. Seems to be running a little bit slow today. But once this loads up, it will give us a full interface with the Jupyter Lab session. Let's try connecting again. There we go. I may have caught it right as it was starting up and was in the middle of something. But we can see here, I have some Python environments that I've already set up for use with Jupyter, as well as just a basic Python kernel. So if I go in here, I can do standard ones. And it will go ahead and respond with kind of what we expect from a Jupyter Notebook session. On the side here, we have kind of our interface. This is always going to default to your home directory. If you have work that's in your project or Scratch, what I would recommend doing is making a symbolic link in your home directory that points to that location. As with Jupyter, you can't navigate up above your own home directory, so you wouldn't be able to switch to your project or Scratch area without a direct link from your home directory. Once you're done, just like with the visual session, you can just close the tab and click the delete button, and it will end your session. Similarly, for our other software, in this case, RStudio, we'll have pretty much the same interface here for designing what we'd like for the job. But in the case of R, we also have a number of different versions because we know that in the case of R, some users would like to use plugins that will only work with certain versions. So we provide 5 different versions right now of R that can be utilized. So by default, I'll select the newest one of 4.5. And if I click launch, it will start up and try to launch your session again. And while that's running, if I've for some reason would like to have a couple of different ones, I could even go while this is running and start another session. So in this case, we have our MATLAB, and I just want to start with one session. And I'll use my other allocation code here. And when I click launch, it'll take us back here. And we can see the RStudio one has already started and MATLAB is in queue. Just like with JupyterHub, RStudio and MATLAB will have a connect to RStudio or connect to MATLAB. We can click and it'll take us to the RStudio interface. MATLAB does take a little bit longer to start up, so I just kind of wanted to show that off RStudio first. But I can actually connect to both sessions, and again, MATLAB can take up to several minutes for starting up. So for the moment, I'll let that start up, but I can take a pause here while that's loading and try to answer any of the audience questions that we may have.
So Josh has a question. So what are the advantages of selecting GPU nodes instead of CPU nodes and vice versa? Similarly, are there any rules of thumb when it comes to choosing the number of cores?
Sure, I can go over both of those. So generally, if you have software that can make good utilization of a GPU, that is when you'd want to select it. So that would primarily be the case of Jupyter if, say, you're using something like PyTorch within your Jupyter notebook and you wanted to use GPU acceleration for that. Or maybe you have some GPU accelerated software that you'd like to use with a cluster desktop. In those cases, picking a GPU accelerated node will give you access to one or more of the GPUs there. I can actually show that off here. So say I wanted to start up a Jupyter notebook. In this case, I actually want to do a GPU. So I'll select my GPU allocation code, a GPU node, and now rather than asking for how many CPUs, it'll ask me for how many GPUs I want. And when I request GPUs, I'll always get 6 CPU cores per GPU I pick and 24 gigabytes of memory per GPU. And this is system memory, not GPU VRAM memory. Our GPUs are NVIDIA V100s, and by default, the ones that are on our interactive queue utilize 16 gigabytes of VRAM. As for selecting the number of cores, that is a bit up to the software itself. Generally, my guideline would be figure out roughly how much memory you need to utilize for the software, and then select the number of cores based off of that. So in our case, all of these systems, if we select CPU and pick a number of cores, we're going to get 4 gigabytes of memory for each core that we request out of the system. So if I request 6, I'm going to get 24. If I only need 16, I could request 4, and that would give me the 16 gigabytes of memory. Does that answer your question, Josh? Of course. Okay, so I can now show off. Here's the MATLAB interface. Again, it is a brand new piece of software, and MATLAB does have a bit heavier of an interface than RStudio or Jupyter, so it takes a little bit longer to start up. But much like the other ones, it also can add 2+2. Once we're done with the sessions, we can always go back and view what my interactive sessions are here. You can see that both these are running. They will time out on their own. So if you leave them running after 55 minutes or an hour by default is what we set for these, they will end the job just like any other job on our system. But if I want to end them early, I can just generally click delete, and it'll clean up the little card that it creates here. As well, these tabs will basically stop functioning. They'll say that it can't connect to the RStudio server or the MATLAB one. And I saw the question in the chat, for RStudio, would CPU nodes be better? Generally, yes. I don't know of any RStudio packages that can make use of GPUs, but it is available in that case of somebody has a very specific package or add-on for RStudio that may be wanting to utilize a GPU rather than a purely CPU node. All right, to wrap up, I'll just show off this help menu here. If you run into issues, you can actually click here to contact support, and it'll open your mail client to send an email to our ARC support at ubc.ca. Or if you'd like to view something on our online documentation, you can click on this online documentation button, and it'll take you directly to our Confluence documentation. On ARC OnDemand, we can see below here, we have a lot of the topics that I just went over through the session today, including how to utilize a notebook, RStudio, and MATLAB. Once I'm done with the session, I can click the logout, and it will log me out just like it will from any other UBC system. Let me jump back to the slides here, and we'll wrap things up. So this is just a few backup slides of kind of going over the interface on here and some of the topics that we just went through. So finally, to wrap things up, we'd love to hear some of the feedback that on what you thought of this session. And we have this QR code and link in the slides for a quick 5-question survey. And to help encourage you to fill out our survey, everyone who participates will get entered in a chance to win a bag of some UBC ARC branded swag. We're going to have the draw take place in April, and we'll notify whoever wins via the email. And I'm happy to stick around for the next 15 minutes if anyone has any questions. Rachel, is there anything you'd like to say to wrap up the session with? You're still muted, Rachel.
Yeah, for sure. Thank you so much, Jacob. Thank you all for joining us today. We hope you found the session helpful and informative. A reminder that recording will be shared with you afterward, along with the deck covered during the session. If you have any additional questions that we didn't get to feel free to stay. So like Jacob said, he will be here for a couple more minutes to ask the question, or send an email to arc.support@ubc.ca, and we're always happy to support you in your work. A big thank you again to Jacob for leading today's session, and we wish you all a great rest of your day. We hope to see you at in our future sessions. Thank you.
Yeah, thank you.